Hello, my name is Adam Simpson. I'm a product manager with Nokia, and today I'm here to talk to you about automation. I'm going to show you a demo of using automation in a practical network scenario. I'm going to show you a demo that involves 5 or 6 Nokia routers running the SROS operating system and being interacted with using the open source RPC framework called gRPC. We're going to use the gRPC framework to collect streaming telemetry from the network elements. We're going to ingest that stream telemetry into an open source database system called the Elasticsearch database system. And then we're going to use that data to close the loop between intent and outcome, to actually program a change in the network in order to achieve a desired outcome. Let's take a look at the demo. The first thing I'm going to do here to show you the topology of the demo is to log into the Nokia NSP management platform. We're going to take a look at the topology in our service fulfillment application. The topology we're going to use in this demo is a 6-node topology with 2 PE routers, one on the left, one on the right, and there's a northbound path between the PE routers and a southbound path through the PE routers. Most of the connectivity between the routers that are shown in the topology is 100 gig and 10 gigabit Ethernet. And from a service perspective, we have one vPRN service that is instantiated on both PE1 and PE2. And that service, we're going to suppose that it's a service created to meet some very strict latency requirements. So let's go in and first of all do some setup. I'm logging into the PE1 node that was on the left of the topology, and I'm using our model-driven CLI. I'm going to go in and enable some of the elements to enable streaming telemetry. So I'm going to enable FIB telemetry. I'm going to also enable our RibAPI programming interfaces. This is a gRPC-based interface that allows programming of the routing tables. I'm also going to enable GNMI, which is the management interfaces that uses gRPC. And as you can see here, I'm enabling the gRPC globally. I'm not worrying about security at the moment, but a production deployment would. And I'm going to enable 2 services under gRPC. I'm going to enable the RibAPI and GNMI. So we're in the model-driven interface here, and we can look at the candidate configuration before we go ahead and commit it. It all looks good. I'm going to commit it. And now we can see that we've got the basic setup. So the GNMI is up and running, the RibAPI is up and running. We currently have no gRPC connections yet, and we have no subscriptions to state data. I'm now going to go onto a Linux node, and I'm going to set up some subscriptions into that node. And the data that's created by those subscriptions is going to be forwarded to the Elastic database. Let's go back into PE1, take a look at the Rpc Connections. So there's actually 2 RPCs that are into this PE1 router. And they're 2 different subscribe RPCs. So these are for streaming telemetry. And if we want, we can actually see the Yang state paths that are actually being monitored or collected for telemetry purposes. So the first of these subscriptions is going to be for a set of 3 paths, which is basically collecting the route table of the PE1 router, the tunnel table of the PE router, and the label FIB. And those subscriptions are all on change. So we're going to pick up all the on change events that happen to those tables. And in fact, we're doing this on all the other routers in the topology as well. The other subscription that we've got is to an OEM PM session, which is going to stream telemetry, and it's going to give us latency and jitter through that subscription. Now I'm logging into the Kibana front end of the Elastic database system, and Kibana is going to give me the ability to visualize all the data that's being collected, the telemetry data, into the Elastic database. So just to take a look at what's here, we're taking a look at the port stats that are being collected by all the nodes. That's one of the subscriptions that we have. And you can see here that we're collecting in and out traffic on all the ports that are forwarding traffic in the topology. Some of the other data that we're pulling into the Elastic database using streaming telemetry is the route table events. So these are on-change events, any changes to the route tables of all the routers. So you can actually see different nodes in the topology here are reporting changes to the route tables. And then we can take a look at events to the tunnel tables of the routers, and we can also take a look at events that are happening to the label fib. So we're getting all this streamed on change into the telemetry database. And then what makes this really, really powerful is we can also stream in latency measurements and jitter measurements end-to-end between the two services. So we talked about a VPRN service in PE1 and PE2. We're streaming data about the latency and jitter between those 2 points, and you can see those represented here. IFDV average is the jitter, and FD average is the delay. This is the visualization dashboard of Kibana that we're looking at now, and we're just visualizing a few of the data points being collected. The port stats are being used to represent a bandwidth in the left-hand side of the screen here, and then there's a gauge on the right-hand side showing the end-to-end latency between the PE1 VPRN and the PE2 VPRN. Everything is very much under control now. But let's introduce a real-world problem. Let's introduce congestion on the northbound path, which is the way the traffic's currently flowing. So I've used an Ixia traffic generator, and I've flooded a huge amount of traffic. And you could see that as soon as I did that, the round-trip delay that was being measured between the two endpoints shot from 400 microseconds up to 80,000 microseconds. So we have a bit of a problem. So how would we solve this in a closed-loop way? Well, what I'm going to do is I'm going to go in and use our RibAPI programming. And I'm just going back to the Linux node again and running some scripts that is changing the programming. So I'm using the open interface to modify the routing tables to set up a new segment routing path on the uncongested southbound path. And you can see here that the bandwidth generated by the Ixia is still running very, very high rate, but the round-trip delay has dropped back to 300 microseconds. So the problem was solved. So if we take a look at what we've actually done, I'm going to log back into the PE1 router, and I'm actually going to take a look at the state that was programmed from the Linux agent that I created that ran the script. So I added a tunnel using the RibAPI programming, and that was a new tunnel for the PE1, PE2 service. And I did some label programming, and here's the result of that in terms of a new tunnel table for the router. So here you can see full automation in action using gRPC as the mechanism of interacting between a client and the routers in the network, using stream telemetry information, collecting it in an open source database, visualizing that, and then reacting to it in a closed loop way by actually using the programming interface to fix the issue. In this case, the issue that was demonstrated was one where latency was affected on a critical service by congestion, and we moved the traffic to a lower congested path in order to solve that latency problem. So what have we seen in this demo? We've seen closed-loop automation in action. We've seen taking an objective, which is minimizing the latency for a particular service, the round-trip delay. We've taken that objective, monitoring that the objective is met, and when it wasn't met, we actually saw using an open programming interface into the routers in order to correct the problem. That was using the gRPC-based RibAPI. This is an example of real automation that can solve real problems. Thank you for listening to this presentation. I hope you found it useful and interesting and relevant.